Okay, hi everyone. Today we're going to match our polynomials to our graphs, okay? Polynomials to our graphs. And one way we're going to be able to do that is by looking at the characteristics that we talked about in the last 3 weeks that we've been working, okay? Last 3 weeks. So for instance, I see positive x squared. Let me go ahead and copy this again. If you look here, I have two equations, two polynomials, 2x squared. I'll pick a different color. We have 2x squared and we have negative x squared, okay? So we're going to use the characteristics we talked about before with end behavior to figure out which of these are going to match. Now, this is a positive x squared, okay? Positive x squared. So on the right side, as a graph goes positive, what's a positive times a positive? Because x squared is really just positive times positive. So what's positive times positive? That's going to be positive. So we can see, hey, it's going to go up. Yeah. How about double check negative and negative? Because again, x squared, no matter what number you plug in that's negative, negative is going to be positive. So we see this is also positive. Over here, we see that they're both negative. So of course, this guy is going to be related to this guy and not that guy, right? Not that guy. Now I want to make sure you guys understand over here that this actually matches up. We have a negative 2x squared. That's my leading term. If you look at it as negative 2, and we're going to plug in a positive and a positive. So that's a negative times a positive stays negative. On the left side, a negative times a negative times a negative. Let me show you how I got that. Negative 2 times x squared, right? That means we have two x's. And negative stays negative. And you can see that this graph is both negative on the left and the right side. And that's one of the first tools we have. Does this graph exit to the right, up or down, positive or negative? Okay. Let's go ahead and match them. This isn't one of the easiest ones. Here we go, submit, see what happens. All right. Now, we're going to use the same type of skills here for all these other problems. So I'm going to look at this as x cubed. So that's going to be x in a sense, right? But over here, it's going to be negative x for x cubed. We're looking at our leading coefficients. So if I went to the right, a positive times positive stays positive. Does not look like we ended up positive, right? We had to go this way. So it's the wrong graph. But of course, if I look on the one to the right, we do end up shooting up to the right, positive, okay, on the right side. On the left, a negative, because we had x cubed. This stays negative, right? So on the left side, we're going to go down, negative. Okay, that does match up. On the right side, just to verify, a positive. Don't forget this negative here is negative. So that gives us a negative value. Negative times positive stays negative. As you can tell on the right side, we are negative. On my left side, negative from the negative to begin with, right? That's this negative. We actually have 4 negatives. That means it's going to be positive. And we can see it being positive here. Here's another easy way of looking at it. If I plugged in, looking for the y-intercept, if I plug in 0, 0, 0, my only number is 63, this looks like eventually it will hit 63, yeah? Not this guy. This guy was something like negative 7. And looking over here, if I plug in 0, 0, 0, we do see a negative 7. Just to double verify what we're guessing. So there's two things that we're looking at right now. We're looking at not only the end behavior, positive, negative. We're also looking at the y-intercept, which is just another added reinforcement. Just, again, saying, hey, yeah, you're right, you got this. So we know positive at the right, negative on the left, negative on the right, positive on the left. Okay, so I want to use these skills consistently for all these problems here. So for the first problem here, let's look at this guy. It's going to be positive. You don't need to do the parentheses because we're just testing it, right? That stays positive. But on the left side, negative. That becomes positive, right? So both the right and the left side are both going to be positive, and we only see one possibility here. Just to double check, Our y-intercept, if it's 0, 0, it's going to be 2 here. That's going to be 2, and it does hit 2. And you guys have to practice this skill to make sure like you're not just guessing. We're not just guessing. We're not just crossing our fingers. Okay, we see it as negative, and then we have 1, 2, 3, 4. Okay, if I go positive, 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 because of this negative, it stays negative. So on the right side, we're going to stay negative, and you can tell here we went down negative. What about on the left side? Negative, negative, 1, 2, 3, 4. That's negative, negative is a positive, positive, and negative still, we become negative. And you can see that's negative over here. So the end behavior, us understanding how to figure out the end behavior of each of these graphs actually really helps a lot. And just double check if I plug in 0 and 0, our last value is, our y-intercept is going to be negative 3, and you can tell here, automatically negative 3. Okay, let's jump. Now these questions look even more crazy, a little bit more crazy, but we're going to do an extra step here, not only to validate our end behavior, our y-intercept, but we're also going to do one more. We're going to validate our zeros. So looking here, let's look at, they gave us our 2 examples. So our first problem, let's look at the top. We have x to the 4th, but do you see how it's negative? So for sure, I know the right side is going to be positive, 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 and then negative, that's going to go down on the right and up on the left. Wait, sorry, down on the left also. I'm sorry. Down on the left. How do I know that? Positive, 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 positive with a negative in the front stays negative, and negative 1, 2, 3, 4. That's still going to be negative. So we're negative on both sides here. Not only are we negative on both sides, they told us the zeros. What's the 0 that would make this go to 0? It will be 0 at positive 1. X equals to positive 1. So not only do we know that it's going to go down on the right, down on the left, but we also know that it's going to be 0 at 1. Let's take a look at the graph on the right. We do see a 0 at 1. We do see the right is negative and left is negative. Also, one more thing. What's the multiplicity of my root? What's the multiplicity of my 0? Happens 4 times. So the multiplicity is 4. That means it's an even root, right? So what happens at the even value? We bounce. Take a look here. We went up, we bounced, and we came back down. So this graph on the right totally matches that equation we have, our first equation. The second equation, let's take a look here. X cubed, that's positive, positive, positive on the right stays positive, and negative, negative, negative stays negative on the left. So we're looking at positive on the right, negative on the left. That does match up with what I'm looking here at my first graph. Let's take a look at the roots. The roots here, what would make these numbers go to 0? It would be negative 9 and negative 7. Let's look at the root here. We do see a negative 7 and negative 9. Those are both roots. Very good. Not only do we see that they're roots, we can say that, hey, the multiplicity is even at 2. Even at negative 7, so we bounced here. And these are our takeaways for all the work that we did before about factoring polynomials. Once I learned the factor, I could graph this without really much work to a reasonable reasonable proximity. Okay? Like it's good enough. Now, these aren't super hard, right? Because we're just going to match them now. We said this here, this here. So the cool thing is that they end up factoring for you these problems. Let's go ahead and jump up and make this even more crazy. Now, they gave us 4 different possibilities here. So we make sure we don't want to mess any of this up, because if we mess up one of these graphs, or sorry, you have to mess up in pairs at least, for sure it's not going to work out. So let's make sure we're cool with this. First thing, let's go ahead and figure out which one's going up and which one's going down. Okay. Over here we're seeing x cubed, so it's negative sorry, negative, and then 1, 2, 3, negative 1, 2, 3. So on the right side, positive, positive, positive. This is still going to be negative, and negative, 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 that's going to be positive. So which of these graphs? The left side is up and the bottom is right. Left side is up, bottom is right. It looks like this is my only choice. Not only this, look, the y-intercept is 72. And this looks like it's going to be 72 up here. For sure, not this one, maybe this one, and not this one. Okay? So just because you know the y-intercept, that isn't enough for you to make that a good guess. This one does look like eventually it'll probably hit like the 72 that we're looking for. All right, so we got one of these. Let's look at another. Let's look at this one here. So it's negative 1, 2, 3, 4, or you can just write negative 1, 2, 3, 4. Is that going to be positive or negative? That's going to stay negative, right? So we're looking at the right side, it being down. Left side 1, 2, 3, 4, and we have a fifth one, right? That's going to be a negative also. So we're looking at the left and the right going down. Okay, which of these options, left and right side, are going down? I see it's probably going to be this guy here. Take a look. Both left side and right side are going to be going down. And just to verify that, our y-intercept is negative 1. That does look like negative 1. So using our tools that we learned about from before, about end behavior, we can verify which of these graphs are going to be it. Okay, this is going to be G. This is F. Let's finish the last two. X cubed, that's positive, 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 negative, negative, negative. So it's going to be positive on the right, negative on the left. Of our last two choices, it looks like this is going to be our H. Double check, our y-intercept is 343. That's way up here. See, it ticks off. All right, I'll take that. And then the last one, for sure, it's going to be positive, 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 negative, 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 positive, and positive. As you can see, positive and positive, right? And we have y-intercept. If I plug in 0, 0, 0, 0, that is going to be 0 here. Okay, let's jump. Now, this one here helped us a little bit more because they gave us a factored version. So I want to do this with leading coefficients and factoring. So let's find out the zeros here. The zeros here are going to be negative 3. The zeros here are going to be negative 3. And if you look here, that's actually an imaginary number. X squared plus 1, will this ever become 0? X squared equals to negative 1. X equals to plus or minus the square root of negative 1. No real zeros. Okay, and we'll talk about conjugates the next time we see each other in class. But there are no zeros here. So the only zero here is negative 3. All right. So which of these graphs have a root at negative 3? Wait, negative 3. Which of these graphs have... Oh, see, only one graph here. Negative 3. So of the 4, no one else here has a negative 3 on the graph. So great, I can identify which graph just by that root. Just to verify, we have x cubed, positive, positive, positive means positive on the right, negative, negative, negative means negative on the left. This does go positive and negative. Positive on the right, negative on the left. The second one, G, we said that x squared plus x squared plus, this would actually always be imaginary. That means there's no zeros for this problem. And the only graph that has no zeros for the problem, it looks like this guy here. Just to verify that, we have x to the 4th. That's positive, 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 positive stays positive. Negative, 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 negative stays negative. Nope, stays positive again. So they're both going up. Left and right side are going up. So it could have been this guy or this guy. What's the y-intercept? Just to add to that, the y-intercept is 3. Plug in 0, we end up with 3 left over. Looking here, our only option left is 3. All right, so that double affirmed. Okay, let's look at the next problem. H, my 0 is at 5. Let's take a look. I do have a 0 at 5. I have no 0 here at 5. Now, at 5, we see the multiplicity is going to be 3. So it's a cross, and we do cross at the 5, x equals to 5. Not only that, x cubed here, positive, 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 negative, negative, negative. We are positive on the right, negative on the left. The y-intercept is negative 125. This is going down to negative 1 something, negative something. So these characteristics are helping me make sure I've identified which graph matches which equation using pretty much everything we learned in our last test. And the last one here, negative 1, 1, and 2. Let's see if this matches. Negative 1, yep, 1, and 2. Take a look here. We do have a bounce at negative 1, so we should have an even multiplicity. Looking at my question, we do have an even multiplicity. We do, yes we do. And also our y-intercept 0, 0, 0, my y-intercept is 6. So take a look here. The y-intercept is, oh my gosh, 6. It's everything that we talked about. Okay, so we're back to again matching the polynomials on the graph. So which one would this one be? I see okay, I want you guys to go ahead and make a guess here. X to the fourth, positive, 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 negative, 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 negative. Which of these four graphs would match that using just the end behavior? Which of these is positive, 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 positive on the right and negative, 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 negative on the left? This would be a positive, this would be a positive, right? So hopefully you guys would see that would be only this choice. Double checking that. The y-intercept is 1. The y-intercept is 1. Yeah, that looks pretty good. Okay, let's look at x cubed here. X cubed is positive, 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 negative, negative, negative. So positive, positive, positive is positive on the right. Negative, negative, negative is negative on the left. Positive and negative, that's my only choice here. Okay, negative x squared. So that's negative, positive, positive, and negative, negative, negative. Again, where did I get the extra negative in the front? It's because, remember, the front of the problem is originally negative here. The problem is originally negative. So we have a negative on the right and a negative on the left. So which of these graphs are both negative? We can see that's a graph over here. With a y-intercept of negative 8. Yes, y-intercept is negative 8. And last one, negative, looking at end behavior, negative, positive, 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 and negative, 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 negative. So this would be negative and this would be positive actually. So left side is up, right side is down. Left side is up, right side is down. Okay, so and then this goes back to again what we did before, right? It gave us our roots and our polynomial. And so check the end behavior. So your homework is pretty much this. This is it.